In this video, I'm going to give an overview of interfaces in programming. Not user interfaces, but interface as a variable type. I'll have a follow-on video where I go through some examples in code. This is just an overview. So first of all, why interfaces? I want to tell a couple stories from my career. Early in my career, I took training from Sun Microsystems, which at the time was the creator of the Java programming language and the owner of the Java programming language. And the instructor told me one thing that really changed my perspective on programming. I didn't know what he meant at the time, but about 9 months later, it all made sense. He said, if you're not using interfaces, you're only using half of Java's potential. Wow. So where do you use an interface? Well, let's remember what polymorphism is. Polymorphism, variable type tells you what methods you're allowed to call. An object type tells you what happens when you call those methods. Now, let's look at this through the lens of the solid principles of object-oriented design. We're kind of going in reverse order here, but we'll start with the D, which is dependency inversion. So a class should depend on abstractions, not concretions. In other words, if we take a look at this class diagram, you see that our driver, which is a UI prompting class, and our inventory reader, which is reading a text file, deals with the superclass called vehicle as a variable type, and it doesn't directly tie into the subclasses, but those can be object types. Well, we can take this a step further with an interface, because really a variable only needs to be a list of methods. It doesn't need more than that. Anything more, and you're putting more information in it than you need to, which is complicating it. Interface segregation. A client should not be forced to implement an interface it does not use, or a client should not be forced to depend on methods they do not use. For this one, I want to go back to a technical interview I had about 10 years ago. I asked the candidate to give me a good use case of using interfaces, and his answer was perfect. He said, I'm a person. That's my class type. When I am at work, I'm a coworker, so I put on my coworker interface. When I see my wife, I'm a husband, so I put on my husband interface. And when I see my children, I'm a father, so I put on my father interface. I have different interfaces for each context because I don't want my coworkers dealing with me as my children would. I don't want my wife dealing with me as my coworkers would, and vice versa. So I expose a different interface depending on who I'm dealing with. But under the covers, the whole time, I'm always a person. So that's essentially what interface segregation is let's make interfaces that are very specific, and let's not overload them with too many methods. Let's give them the right methods at the right time. And then finally, Liskov Substitution. Every subclass or derived class should be substitutable for the base or parent class. And once again, we think about our class diagram here, where we know that our driver and our inventory reader are dealing with the type vehicle, but Sonic, Mustang, and or Prius can be substituted for that vehicle, and oftentimes that is the case. So vehicle in our case is a class, but it could just as well be an interface, and that's really the value of interfaces, is that they can be a variable type. So that's a quick overview of interfaces and how they interact with solid. Following this, I'll do an example, and we'll take a look at it in code. I hope you found this helpful, and I look forward to reading your comments. Thank you.